Hi, everyone. I'm joined here today with Andrew Watson, who is the author of the Goldilocks Map, and he is an a teacher coach. Is that correct?
I do coaching. I do presenting for faculties and students and parents. So if you're at the intersection of cognitive science and learning, that's where I am.
That's awesome. So I have to admit, I recently met Andrew Watson at a Research Ed conference, and I thought he was really phenomenal when I spoke to him about education. I had to have him on the podcast. Um, and we're going to be talking a lot about research today, which is what his book is about. And, they think there's sort of two schools of thought on research for teachers. I think, the one school of thought is that teachers are busy, research is hard to understand, teachers shouldn't be taught how to read research, and that we should just point them in the direction of qualified experts. Personally, I'm really not a fan of that model because I think it leads us towards this sort of guruship problem where we have um, people who become popular not necessarily because they're um, the most qualified or because they provide the most apt answers, but because they provide the most compelling answers or the most marketable answers. And I think that's been sort of the crux of the problem in education overall over the last, well, since I became a teacher, I'll put it that way. Um, and your book is really, I think, meant to provide teachers with a guide to understand this topic. So
Exactly that.
this is a topic that I'm really passionate about also. So I think we can have a really great conversation about this. And I'm going to start off by just asking you, what is cognitive science? That's a term that, I've seen really popularized over the last, I would say like 18 months. And I'm
Mhm.
starting to see really used more and more.
Yeah, so I guess one thing I think of is making that plural, cognitive sciences, as much as cognitive science. But I think in a straightforward way, it is what the name implies. You know, cognition has to do with thinking. So cognitive sciences are different scientific approaches to understand how thinking happens. And of course, thinking is an extraordinarily complicated thing. So there are all sorts of nuances and approaches and alternative avenues we could pursue as we think about that. But for me, a shorthand is cognitive science is the study of thinking.
Awesome. So I think another term that I think sort of gets lumped in with cognitive science as being one and the same is neuroscience. So what is neuroscience?
Yeah, so neuroscience is an important subset, or can be an important subset of the category cognitive sciences. So essentially, neuroscience is a branch of biology. So if I'm a scientist and I study how the kidneys work, the kidneys are a biological organism, part of my body in my organism. Uh, so there's some, I don't even know what you would call that scientist, but there are scientists who study kidneys, or scientists who study lungs, or scientists who study muscles. So neuroscience is the study of the brain, basically, um, in a very biological way. So when we're talking about, say, synapses, or we're talking about brain regions like the prefrontal cortex, or if we're talking about fMRI research or EEG research, or dopamine or oxytocin. All of these are biological ways of talking about thinking and learning. So all of that is neuroscience, which is one of the many branches that feed into the broader river of cognitive science.
So what is the difference then with, say, psychology research and neuroscience research?
So such a good question, such an important question. So the easy distinction to this complex question you've asked is that neuroscience is basically a subset of biology. It looks at the physical object of the brain. Psychology of the study is the study of the mind, which is some sort of mental projection. When the brain is doing its thing and the synapses are firing and the neurotransmitters and the brain regions and all that, when they're doing what they do, they produce this other thing called the mind. And psychology is the study of the mind. So when we talk about, say, attention or learning or curiosity or cooperation or motivation, all of these are psychological concepts. They can be studied from a neuroscientific perspective, but fundamentally, it's a question of how the mind works. And in the last few decades, these two fields, psychology and neuroscience, have started to come together more into this broader category, perhaps, of cognitive sciences. But for most of the history of both disciplines, they were seen as quite separate, and people who were in either of those two disciplines were really very skeptical of the sort of work that the other did. So it's only within the last, I don't know, 2 or 3 decades that there's been this idea of, cognitive psychology or neuropsychology, that sort of thing.
Yeah, I always thought of it as sort of two halves of the same coin. Like I like to think of it as, neuroscience is the mechanistic element. What is the possible cause of what we're seeing in psychology? And psychology, or, especially where I tend to look more application of learning science, um, it tends to be, what does this look like in practice? What is the result of the mechanism? And I think as of late, there's become this really intense interest on neuroscience in particular. And I have to say, I'm a little concerned with it. And I get the appeal of the draw to neuroscience because, application science, especially in classrooms, can feel messy. And then a lot of the research being done is being done by grad students or by private companies. And it can feel like there's a lot of limitations to that research. And there is. And I think, people hear neuroscience and study the brain and they picture scientists with lab coats instead of teachers with clipboards. And there's this sort of idea, well, this is real science. That application stuff, that's sort of, soft science or pooey, for lack of a better word. Um, and I used to feel the same way when I first started getting into this education research. If you listen to some early episodes of my podcast, you can hear me make comments like, oh, neuroscience, here's the real science. And it's not so much that I don't think neuroscience has a place, but I think there are important limitations that need to be considered. And I recently, or I should say, not recently, I remember seeing a blog by Timothy Shanahan on what he saw as the biggest myths in education, and he listed neuroscience and its popularity being one of the myths. And I believe I saw a few years ago too, Steinberg also commenting about the limitations of neuroscience and being concerned that people are over extrapolating on the possibilities of it. And I know this is something you have talked about. So I was wondering if you could share your insights as to why we need to be cautious about over extrapolating on neuroscience. And I don't think you're criticizing neuroscience, for the record, but I think you are saying we can't just throw out skepticism when it comes to neuroscience.
Yeah, gosh, Nate, there's so much to talk about in answer to that set of prompts there.
Sorry.
So we absolutely live at a cultural moment when neuroscience has great cultural power. And really all you have to do is say, brain research shows, and suddenly everyone thinks, well, it's really not possible to argue. Once someone says that brain research shows, the conversation is really done. We just have to do that. And there, I should say, I myself plead guilty to this. The name of my consulting company is Translate the Brain, because when I started it, I was really all gung-ho about neuroscience research. And I think, like you, I've come to realize that was over enthusiasm about a field which can't really give us the kind of advice that we want. So there's an analogy I sometimes use, Nate, and maybe this will be helpful. So if we think for a minute, I'm going to pretend that I'm a neurologist and I study migraine headaches for a living. So I hang out with my patients and I use my fMRI research and I look at the amygdala and I look at the synapses and I do all the good neuroscience-y stuff. And what I realize is there's a particular sort of neural signature when my patients have a particular kind of migraine. This is what's happening in the brain at that moment. So what I want to do now is to disrupt that particular neural signature as a way to make the migraine go away. So I develop some exercises and I test some drugs and I check it out on the mice and it's perfectly safe. And I check it out on my humans, and sure enough, it does disrupt that neural signature. And so I start selling the Watson method of migraine. Oh, wait a minute, Nate, I think I skipped a step. Because the step that I skipped there was I actually need to stop and check whether or not the migraine went away, because it's lovely if I successfully disrupt the neural signature. But if I disrupt the neural signature and the migraine is still there, then it doesn't matter to my patient whether or not I disrupted the neural signature. They care about the migraine, not about the neurobiology. And equally important, let's say the migraine does go away, but the neural signature doesn't change, then it still doesn't matter what happened with the neural signature. What the patient cares about is the migraine, not actually the neurobiological underpinnings of that. And the same is true in the world of brain research, that all of these cool things that we talk about with, synaptic formation, which is absolutely fascinating, or what happens in the amygdala as a result of the, activation of the HPA axis, or what dopamine is doing, or what oxytocin is doing. All of these are fascinating, but as teachers and students, what we care about is, did the student remember better? Did they learn more? Are they concentrating more effectively? Are they cooperating more cooperatively? Are they expressing more motivation when they come to class? Uh, and honestly, it doesn't really matter to the teacher and the student what the dopamine blend is that's causing that to happen. It's cool, but it doesn't really matter. What matters is whether or not they're cooperating. So much of my concern is the struggle to get this balance right, where we're drawn to neuroscience research because it's so interesting. And what I see a lot of, and what makes me nervous, is people say, here's what dopamine does, and therefore you should teach this way.
Hmm.
And my own view is, what you can say is, well, here's what dopamine does, which generates the hypothesis that you should teach this way. So we then tested teaching this way and measured whether or not doing that had an actual effect. Uh, and maybe the neuroscience research sort of prompted us to go look, but we actually need to stop and measure whether or not it has the effect in the classroom that we want it to have. And so many people skip over that intervening step that they end up giving teachers very confident advice, even though they don't have a good reason to be confident.
Yeah, I love that answer. And I think we just have to keep in mind that there's a sort of proportionality to this, that just because you have a mechanism or a plausible mechanism doesn't mean that it's actually going to work in practice. I mean, there's a big difference, I think, between what you can do in a lab under a controlled setting with a limited number of participants versus what you can do in a classroom with 30 kids. And I can see it going both ways too. I mean, we have that one brain study that showed that if students memorize words versus if they orthographically map them, that it changes where that information is stored in the brain, and that the part of the brain associated with fluent reading was where the orthographically mapped words were stored. But that seems to sort of back up why we see in application research tons of studies showing that phonics is beneficial to kids. But if we just had that, neuroscience study and we didn't have the application science showing phonics works in classrooms, I would be far more skeptical. And just to piggyback on what you're saying there for a moment, I remember before I was into education science, I was really into science of fitness. It was part of what got me into education
Mm.
science. I remember there was this famous researcher in fitness who figured out that you can measure the activation of muscles through EMG machines. Um, so he did a whole series of experiments where he hooked himself up to EMG machines and then measured the activation response for different exercises on different muscles. And he didn't even peer review a lot of this, which I actually think is fine because the research was brilliant. It was amazing. But as others later pointed on, just because he was able to activate the muscle better doesn't mean that it would necessarily translate to higher force production for athletes or for greater hypertrophy gains, building a muscle. And then, in fact, there was some research on it that seemed to show that EMG activation did not necessarily correlate well. And I think, some people then might get angry at the researcher for having a wrong hypothesis. And I think that's also a sort of folly thing. I think we need to accept that sometimes we can be wrong and that that's part of the process, the scientific process. This whole idea that people need to be right all the time worries me a little too, because I think, journals tend to dismiss literature that shows negative or null findings, but that negative and null findings is just as important as that positive findings.
So Nate, I'll tell you a story about this last point. I read a series of a series of tweets. I don't know, was it a week ago, 2 weeks ago? And it was an author saying, okay, so I made a mistake a year ago and I need to explain how I made the mistake and why I made the mistake and retract the mistake. And he very carefully went through and said, I read this study. I was really in favor of the study. And I wrote about why I liked the study so much. But now a year later, I realize here was this particular problem, and here was this particular problem, and here's this particular problem. So I want to officially retract my support for this particular study. And Nate, this might sound familiar because you were the person who did that. And I think you are a real model for people who you're both willing to make strong claims based on research, and you're willing to reconsider those claims based either on subsequent research or on further examination of that research. The nature of the scientific process is we do the best we can do with the knowledge we have. And when we get better knowledge, we say, research no longer supports that. So we need to move on from there. So hats off to you for that excellent example.
Well, thank you. Although I do have to admit, I have another retraction coming up soon. I'm actually just waiting for a co-author to help finish the part of the paper. Um, but I just, you do see it sometimes though, where researchers or authors or speakers will get disproven on a concept, and they'll dig their heels in for 10 years trying to claim everybody else is crazy and everyone else is wrong. And I just feel like, it's probably better off for everyone if you just move on with your life, accept this hypothesis was wrong, and get a new hypothesis, test a
Yeah,
new idea. But
yeah.
so going back to this, I think in general, a lot of your book is about skepticism. Would you agree with that? I'm going to
Oh,
pull up the book
absolutely.
again because it's a great book. By the way, he did not pay me to endorse this book, although I am endorsing, in fact.
Oh, well, thank
Um,
you.
uh, is there a value for more aggressive skepticism in education?
Oh, absolutely. I think you mentioned earlier on, um, we work in a very fatty field, and about every 6 months or a year, some new cool thing comes along that we all have to be excited about.
Yeah.
And I think partly, Nate, the reason for that is to do what you and I do for a living, we really have to be optimistic. We really have to hold out hope that things can be better later on, because otherwise, when I'm teaching my students in February, if I didn't believe May would be better, I wouldn't make it through February. Our job really invites us to be optimistic. So I think we're always excited about new potential. And gosh, teaching is just hard, isn't it? It's just hard work. So there's sort of this cycle of new ideas that come through. And I'm game for new ideas. If you want to give me a new suggestion, that's great. Where I get especially nervous is when people jump in and say, well, the research shows, or even more reprehensibly, all the research shows. That's actually
Almost
that's
never is true and correct.
yeah, it's a good giveaway. If someone says all the research shows, you know that they don't really, it's not just that that's untrue because it is, but you know that this is a person who actually doesn't understand how research works, because people who know how research works know it's just never true that all the research shows anything. So that's an easy shorthand to know whose research, this is air quotes here, research-based advice to trust, and whose research-based advice is not to trust. But yes, I think when somebody comes along and says, well, the research shows you should do the thing, try the thing. I think saying, on the one hand, being open and saying, that's really exciting. I would love if I could use this new thing. And can we stop for a minute and chat about the research basis of this idea? Because I have some questions.
Yeah. I'll give you an example of that. You know, phonics, I think, is something I've ended up talking a lot about because it ends up coming under enormous debate. And yet it seems to be the thing that we have the most research on. Um, so I think that's a bit ironic, but that does not mean that there's no research out there showing that phonics might have limitations to its research. And there's a bit of a famous or infamous researcher, depending on who you talk to, named Jeffrey Bowers. And I will give him a little bit of a shout out here, although I don't agree with a lot of what he says. He presents the most compelling argument against phonics of any researcher out there because he grounds his argument in research and not opinion and theory. And I think if you're going to look at phonics research, it is actually important to consider the number one skeptic of that topic. I still don't agree with him, but I still think it's important to consider limitations. And I have a paper I've submitted for peer review on this topic, and I actually tried to address the limitations he had addressed in the previous literature in my paper, and I even sent him an advanced copy of the paper. So I'm wondering, he might give me some feedback at some point and say, "Hey, you haven't considered this," or he might be just ready to write a counter paper the second it gets published. Who knows? But I think that's all part of the scientific process, and I think it's important that we try to remove some of the emotional animosity out of this process because I think it sort of builds this team's vibe, and I don't know that that's productive. What do you
Yeah,
think?
So I
Different.
definitely agree about the team's vibe. I think we tend to be in camps in a way that isn't beneficial to learning. And I really like your idea of sending a paper off to the person who's likeliest to disagree with it. One of the suggestions I have in the book. So let's say you heard a speaker talk about the benefits of exercise in the middle of class and all of the way that helps students be alert and pay attention and so forth. And you go and you do some research and you find, oh, yes, indeed, the research does in fact say what this speaker says. So you, as the teacher, you're thinking, okay, now is the time I'm going to start having my students do exercise in class. So I think one of the key steps after you've checked out the research to be sure it supports that claim is then actively to go seek out the research on the other side of the question. And there are a number of different ways to do it. Something as simple as, type into Google exercise in class controversy or exercise in class doesn't help or exercise in class creates problems. Just actively seek out who are the people out there who think what you're about to do is a bad idea. And I think one of three things will happen. Either you won't find much which is persuasive, and that's great. So then you can go ahead and do your thing. Or you'll discover there's all sorts of persuasive stuff out there that will change your mind. So that's great because you dodged that disaster. Or the third thing is you'll learn that there are equally compelling arguments on both sides. So you know a more nuanced way. Well, when I'm doing this, I thought it was a research-based approach, but now it turns out I could make that research-based claim on either side. So I'm going to be cautious and observant as I do it to be sure, is this working? I myself teach English to 10th graders. So is this going to help with my students in my English classes? I can't say that this is a research-based initiative purely. I need to double check to be sure that it's working in my world as well. So that invitation to look for someone to push back against you, I think is a very important part of this process.
It's funny that you bring up that example because in my very early on in my career, I went to a TED Talk sort of thing from a neuroscientist who was studying the importance of exercise during class time and its impact on learning and self-regulation. And he made a phenomenal presentation and very compelling arguments. And it made me leave that conversation thinking, the science shows exercise is like the most important thing in the world. And I started trying to bring as much exercise into my classrooms as possible. In fact, um, I actually started volunteering on my preps to take our struggling students from other people's classes to go to the gym to exercise with them in the hopes that it would help with self-regulation in the school. And although I think that had some benefits, in my own personal class, I did not see a strong benefit. So I'm just curious, we're slightly side tangent here, but is this something you've looked into?
So this is, I think, an interesting case at the level of exercise and learning because the specifics of the claim are really important. So if the claim is physical health is good for learning, I think that's undeniably true. And it makes sense. So we actually, Nate, I bet you know this research literature. We have lots and lots of research that suggests that the brain is a part of the body. It's actually physically attached to your body.
What?
Yes, no, I'm not making this up. We have good research on this.
Okay.
And so everything that is good for your body is good for your brain because your body is a part of your brain. So the reason that exercise is good for your brain is that your brain is a part of your body and exercise is good for your body. And there are some specific neural mechanisms. There's a chemical called brain-derived neurotrophic factor, BDNF, and exercise raises levels of BDNF, and that does good thing for synapses and so forth. So that's clearly true. But the question at the teacherly level isn't exactly, is exercise good? The question is exercise during class good? Because if I'm going to give up class time to have my students exercise, that's a different matter than just exercise generally being good. And even more specifically than that, what I could do in an hour-long period, I could teach for 30 minutes, stop and have my students do calisthenics for 5 minutes, and then teach for 25 more minutes. Or I could actually have them exercise while they're learning. But those are even more specific subsets of the claim. And it seems intuitive that if I'm asking my students to, I don't know, run around the track while they're reading Macbeth, my instincts tell me that that's actually not going to help very much, that the act of running is going to distract them from the Macbeth in a way that will make the learning harder. So this is a case where understanding extremely specifically what the claim is, not just exercise is good for learning, but exercise during class is good for learning, or exercise during learning is good for learning. Those are very important, distinct questions, and we need to be sure which one of those the research is actually supporting.
So, I heard this amazing talk about it at the time, and it was very compelling. In retrospect, I'm more dubious, especially due to the strength of the claims. You talked about how your number one, one of your big triggers is research shows or all research shows. And it's funny you say that. Um, I had the same one. And it's funny, I spend most of my spare time writing about what research shows. But whenever I see the claim, research shows or all research shows or science shows or new study shows, alarm bells go off in my head. Because I think in general, researchers don't tend to write like that. Researchers tend to write like, okay, this was the test, this was the hypothesis, this was the methods behind the test, these are the results, and I'm still not sure. This is
Here are the problems, yes.
yeah. So it seems like a probability. Typically, researchers tend to talk in degrees of probability, not in absolutes. Now, in my class, when I listened to this, I started trying to get the students to take a 10, 15-minute break at the end of every class to do exercise. And I remember the person who convinced me to try this was like saying that you really have to wear the students out, that it doesn't work if it's too easy. So I tried to give them very intense bouts of cardio um, at the end of every class. And I had a particularly rambunctious grade 2 class at the time. And it was a total disaster because one, I'm removing 15 minutes of learning time. Two, um, the time it took them to get settled afterwards again was 5 or 10 minutes. And then if you do that every period, oh my God, did that ever add up? It was like 20 minutes wasted a period. And I could not wear out those grade twos. Those grade twos had so much energy. All the jumping jacks and squats and push-ups in the world was not enough to wear out those grade twos.
And
Sorry.
and to go one step further, that as a teaching methodology might work for you because you actually know a lot about exercise, but there are plenty of people, I myself would hesitate to do that. I've seen people exercise from a distance, but I'm not a particular fitness guru, and I would just feel weird. Like, am I going to injure my students if I have them do too much? What's the right stretch? Like, I would be very nervous about doing that without a lot of guidance, because I know a lot about how to teach students to write good sentences. I don't know nothing about teaching students how to exercise well. So that would be an additional layer of concern for me.
Well, so I think we've adequately laid out the problem, and I think um, we're in agreement that there should be some level of teacher knowledge of research and how to know when to trust research. So I think what we haven't really gotten to, how does a teacher know that they have a trusted source, or how do we know that something is evidence-based? What advice would you give a teacher?
Wow.
I know it's a huge question.
Um, so there are some surprisingly easy steps to take. So in my experience, the first and most astonishingly easy step is simply to say, when someone says all the research shows yada, 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 say, that's so interesting and helpful. What's the best research you would recommend? And if the person who's saying to you that research shows something can't tell you what the research is, that's an enormous warning sign. If I come to you and say, Nate, all the research shows says you should put all of your money in this stock, I suspect you would want to see what the research is before you actually put your money in the stock. And if I say, well, I don't know, I just remember reading somewhere that this is the stock you should put all your money in, you would hesitate with that. And I've been astonished over the years the number of times people will make an emphatic research-based claim, and then either not know what the research is behind the claim, or one of my favorite sort of semi-traumatic examples, someone said all the research shows this thing. And I said, that's so interesting. Can you tell me what the research is? And she responded, well, I can't tell you what the research is because you don't have a PhD in neuroscience. As if that matters. Whether or not I have a PhD in neuroscience, you can still tell me what the research is. And the part of this story which is most alarming is that that person actually doesn't have a PhD in neuroscience. So if people can't tell you what the research is or refuse to tell you what the research is, then don't take the research-based advice. That seems pretty straightforward.
Now, what if they have a really good podcast or blog to recommend to you?
So I'm okay with taking podcast and blog advice if the podcast or blog then cites the source. But what you want to be able to do is when you read the blog to click on the link and say, okay, here precisely, this is the research study. This is the pool of research studies that they're drawing on to make this research-based claim. And by the way, I'm also fine with people giving experience-based advice. I can say to you, in my experience, teaching grammar this way has been beneficial. I don't have research to support that claim. I have my experience to support that claim. And you can then make a decision based on your impression of the quality of my teaching, whether or not you want to take my research, my experience-based opinion. It's not that all teaching advice has to be based on research, but if you say it's a research-based opinion, then you should be able to tell me what the research is. So that's one step. And I guess the next step, we've talked about a little bit already, is when someone gives you this advice and says, here's the research, take a quick look at it and do the circumstances in which that research was done plausibly match your circumstances. So I saw someone a couple of years ago make a claim about a particular math teaching pedagogy. And when I looked at the research behind it, the study was done with Brazilian graduate students who were in a dual degree technology program learning linear algebra. And I think it's great that we're studying how people in Brazil are in dual degree technology programs learn linear algebra. I'm glad that's happening. But that doesn't necessarily mean that that teaching technique will help third graders learn long division. Those are very different kinds of learners. So we want to, as much as possible, find research that aligns with our context. If the research was done in a military academy and the teacher works in a Montessori school, that cultural mismatch might mean that the approach isn't going to work where you teach. If you teach in Brazil and the research was done in Korea, South Korea, those are very different cultural contexts. So to some degree, cultural norms might really play into the effectiveness of that particular teaching technique. So I guess step number one, ask them what the research is. And then once you find out what it is, see if the research is a plausible fit for the teaching world that you're in would be two steps that are, there's some complexities in there, but it's doable. Anybody can do those things.
I think that's great. I'm curious, was that math pedagogy problem-based learning or inquiry-based learning by any chance?
Yes, it was.
I just thought of that because when I've looked into the topic of inquiry-based learning in math and problem-based learning in math, there's a ton of research that looks really promising. But if you dig deeper, you realize it's all like upper high school or university age students, and it's all very advanced math. And I find it troubling that that research might be used to, say, apply to a grade 2 classroom or a kindergarten classroom.
Yeah, I saw a PBL study, I'm sorry, project-based learning study, or I think it was more of an inquiry method. I don't remember the specifics. And the participants in the study were medical students in Finland learning how to fill out insurance forms. And again, I think it's a good thing that medical students in Finland learn how to fill out insurance forms. And I'm going to guess if you're in a medical school, you have successfully completed a couple of decades worth of education. These are highly motivated, highly successful, highly academic people. So A, it's good we know that, and B, that methodology might or might not work for students who have less academic success and less academic motivation and who are, 15 years younger. It might work, but that research doesn't necessarily persuade me that it will work.
Yeah, I completely agree. Um, well, I 100% recommend people to check out your book or check you out on Twitter. Where can people find out more about you?
Oh, well, my Twitter handle is Andrew Watson TTB. TTB stands for Translate the Brain. And surprisingly, if my company is called Translate the Brain, my website is www.translatethebrain.com. So those are probably the two easiest ways to find me. I've got that book out. I've got a couple others out, one about working memory and attention, and one about motivation. So all of those are good ways to find me.
It has been a pleasure to have you on the show. I love your aggressive skepticism, and you're
Mm.
incredibly articulate, and you have a lot of excellent dry wit, which
Oh.
must be great for presentations.
Well,
So
thank you.
it's been a pleasure to interview you, and I hope that the listeners get something out of this, and I definitely hope that they check out your book.
Great. Well, and thanks, Nate, for inviting me for the conversation. I always enjoy chances to chat.